free body diagram is one of the main aid that is used for solving static problems in static analysis of structures. Now, what is static analysis? It is the analysis of any particular body or a structure when it is not in movement. So movement is not there. So if we consider the movement of a particular body, that comes as dynamic analysis. So here, in order to make static analysis easier, we convert the structure that has to be analyzed into a respective free body diagram. So here, as shown in this figure, this is a cable image where 1, 2, 3, 4 cables combine together at a particular joint. So in order to analyze this, we need to draw a respective free body diagram. So here, the free body diagram is given where the joint is considered as the junction node, and all those cables arising from this joint is shown in red arrows. So this is the free body diagram or the FBD diagram of a cable joint. Free body diagram of structural elements. The free body diagram is a method that can be used in modeling a structure very conveniently. So this is a convenient method to make the analysis more simpler. So FBD in more precise way is a method that we use to conceptualize a structure or its respective elements so that easy analysis of the same can be carried out. Now the free body diagram, when we look into its definition, it is defined as a graphical, symbolical, and a dematerialized representation of a structure or its elements. So this conversion will remove all the connecting pieces and makes a simpler figure out of a complex structure. So while drawing a free body diagram, all the physical attributes that are on the structures are removed and it is symbolized conceptually. Features of the free body diagram. A simple single line will be used to represent a body or a segment. As I told you, the cables were represented by single lines. We make it more easier for us to understand and analyze properly. The connection will be represented by distinct properties. Now, connection can be pinned or it can be a fixed support or anything like that. In civil engineering, if you look into the study of different kinds of support, a pin joint, a roller support, or any other junction is given by different representation. So the junction will be conceptualized to a set of forces as well as moments. So these forces are reactions at the connection. When it comes to the node, there are internal forces. So these are represented by means of external forces. So this will include the influence from all the members that is connected to that node. So as I have explained before, in this case, this is the node. So those forces that is coming out of this node is dependent on whatever is coming out of this node. So these cables, the stresses in these cables have an influence at what stress is there at the junction. Now, we'll consider a figure below as shown. The features explained before of the free body diagram can be properly explained with this help of this figure. So here this is a street lamp. Now the different stages that are used to evolve a FBD or a free body diagram for this street lamp is shown. So here we have the original image of a street lamp, and this is the concept behind, because we have a main support like this, a vertical support, and we have a horizontal support over which a lamp is being hung. So this lamp that is hanging at the end of this horizontal element has some sort of weight. So that weight is represented by means of an arrow. So when I bring that concept into a free body diagram, it is a fixed support at this end. This is the horizontal element, and this is the vertical reaction that is coming out of the lamp. If the lamp is weighing 30 units, whatever be the units that represent it, I can represent it as 30 hash, let whatever be the weight unit. Now this is 3 feet horizontal element. At the fixed support, we know as civil engineers, we know that at fixed support, there are moments, horizontal and vertical reactions, right? So that is represented by an arrow and a vertical reaction. So if I explain one by one, initially the whole system is dematerialized. Dematerialized means we identify each one and connect it to what the concept is. Here the lamp is dematerialized into a body that is weighing say 30 units. The weight is acting in the direction of gravity from the center of the body downwards here. So hence a straight line arrow heading downwards is drawn from the center of the lamp. The system have a lamp as the only element whose weight is known. Right. So when you look into this, the only weight element that is acting on that particular structure is the lamp. Right. So that I'm representing in the direction of gravity is 30 units. Next, we need to find other forces that will keep this lamp in equilibrium. For this, we look at the left end of the fixed support. Now we identify the forces and moments that will be generated in a fixed support. The fixed support will have a moment, vertical reaction as well as a horizontal reaction. As here, there is no horizontal force, the horizontal reactions can be neglected. Hence, at the left end fixed support, we have a vertical reaction at the moment. So, as there is no horizontal reaction because there is no other horizontal reaction coming, so it will become cancelled. So we are only considering the rotation moment as well as the vertical moment at the fixed support. Next, the span distance can be obtained from which the final body diagram can be drawn. So that is a horizontal element whose distance can be measured and hence the free body diagram can be developed. All those necessary elements of force that is essential to analyze or solve a force system will be included in the free body diagram or the FBD diagram. So FBD is not found essential in simple problems, but when it comes to complex analysis situations, FBD methods is increasingly utilized. More examples of conversion of a load system into free body diagrams are explained. Here in the example, we have a beam that is fixed at one end and free at other end. So here the respective free body diagram is at fixed end we have 3 reactions. At the free end we have 2 K unit coming and the 5 inches is the horizontal distance. So this is the free body diagram of this particular loaded beam. Another example is a 3 different structure system with same loading and support. So here we have 3 different structural systems with different types of loading. Say, the free body diagram for the above structural system can be drawn as the figure below, right? So here, you can see that the internal structural elements have been removed in the FBD diagram. This is because the internal arrangement have no influence in determining the support reaction. So here, these internal elements, the holes and all those things are not considered because they don't really have any influence. So all those elements that have an influence in developing support reactions are consolidated and finally a free body diagram is given. So here the important reactions are from the supports, the load 150 units and 100 units. Here the support units are supports 150 and 100 units and these elements have no role. Right. Now, here also the supports are having a role and as well as the load 10, 100 and 150 is also provided. So there also we have the same free body diagram. And if the loading geometrics and the support are the same, the external reaction will also remain the same. So this is something that you will understand when you keep on doing an analysis by continuously drawing free body diagrams and problems. Hope this video was informative. For more such informative videos, subscribe to Engineering Fanatics. Thank you and see you in the next video.